High-rise buildings succeed with the help of elevators, and it is not the other way around. In terms of both functional and constructional contexts, the elevator core forms the most vital organ in a high-rise structure. However, while the approach to the design is dominated by functional and aesthetic considerations, elevators often become a function of what can be accommodated rather than what should be provided. We need to relook at the way we perceive internal vertical transportations, SOPs, that is standard operating procedures, smarter, and also make it safer and more sustainable in our projects. Hi friends, if you are an architect or an engineer or any professional attached to the construction or real estate industry, then to know the secret and benefits, you can't afford to miss this informative video anymore. Stay tuned and watch till the end and unlock the hidden potentiality. It is a compilation of useful knowledge as available, blended with potential and practical exposures and experiences earned from project sites. Hello friends, myself Avijit Datta. You are watching our YouTube channel Smart Engineers. As you know, in Smart Engineers, our motto is to discuss about the subject matter which are not covered adequately in our college course curriculum, but there is a huge demand or requirement in practical or professional field or in industry. Let's try to bridge this huge gap between the academia and industry and develop our country. Before we proceed further, request you all to subscribe our this informative channel and press bell icon for immediate all future notification and updation. Friends, if you haven't watched our earlier two career advancement videos, that is how to earn IGBC AP certification in next 2 weeks, that too in first attempt, and how to become IBBI registered valuer and earn huge. Please watch them and get hugely benefited. Also, check out our practical research work on pre-stress concrete and how to do APDM flooring, a foolproof solution for building waterproofing, smart engineering approach, basement or underground structure waterproofing, where and how to place construction joints in concrete, second pile shoring system, how to execute and manage deep excavation, use rebar coupler for huge benefits in your project. Do you know the new innovative top-down construction and its advantages? How to check RMC quality supplied to your projects? Whether your project or building is supposed to be a type 1 construction, but you are not aware. How to avoid cracks in AC block masonry works. You will get all these informative videos in our YouTube channel. Please go through and upgrade yourself. Smart management of lift or elevator work package. Disclaimer: this video is prepared for educational purposes only. The intent is to bridge the gap between academia and industry while compiling the subject matter. A few images and videos were taken from the internet for appropriate presentation and fair use. Neither any copyright claimed on those nor any copyright infringement intended. Also, as it is an educational presentation, it shall not be used for any legal or other use. High-rise buildings succeed with the help of elevators, and it is not the other way around. The terms of both functional and constructional contexts, the elevator core forms the most vital organ in a high-rise structure. The world's first successful safe passenger elevator was designed by Elisa Otis and installed in March 1857. This development led to exciting times as designers and architects began to appreciate the possibilities offered by the elevators. Much higher buildings became feasible, eventually leading to the enormous skyscrapers of today. Difference between lift and elevator. Lifts and elevator are synonymous. The only difference is that elevator is an American term and lift is a British term for the same type of machinery. Both are used interchangeably and refer to the device that carries people and goods to different building levels. Types of lifts or elevators based on uses, based on engineering. Few important parts. Now, the $1 million question. What should you do if a lift or elevator falls? To understand that, let's understand the various components of elevators and how it operates.
The lift is a type of vertical transport equipment that moves people or goods between floors of a building. Generally, lift is powered by electric motors that either drive cables, hoist, or pump hydraulic fluid to raise a cylindrical piston like a jack. Elevators are of two types. One, hydraulic elevator. Two, traction elevator. Hydraulic lifts are powered by electronic pumps which transmit the hydraulic fluid to the jack. The lift has a piston at its base which will push it up. On the other hand, traction lifts use ropes, sheaves, and counterweight for moving up and down. Both systems have their own set of pros and cons. Traction elevators are the most widely used elevators all over the world. Shaft. It is also known as hoistway. It is the space in which one or more elevator car moves. This space is enclosed by fireproof walls, pit, and ceiling for the travel of one or more elevators. Headroom. It is also known as overhead. It is a part of shaft between the level of the highest stop and the shaft's ceiling. Travel height. It is the length of cabin's travel between level of the lowest and the highest top. Pit. It is a part of shaft below level of the lowest top. So if we want to calculate shaft height, it is equal to pit plus travel plus overhead. Machine room. It is a special room accessible only for the authorized persons, which contains the lift drive unit, control panel and motor. It is often placed above the shaft on the very top floor. The machine room is an integral part of the elevator. With advancements in technology, the machine room is getting smaller and smaller every year, and some systems even have them installed inside the shaft. They are also known as machine roomless elevators or MRL elevators. Guide rails. They are generally made of steel and their shape is like an English letter T. They are installed vertically in a shaft to guide and direct the course of travel of an elevator car and elevator counterweights. Drive unit. Drive unit is generally placed in machine room and it is used to operate the movements, speed and torque of an elevator. If your elevator often suffers from slow starts and stops or seems to make sharp, sudden movements, the drive could be to blame. Control unit. It is also known as controller or control panel. It is placed in machine room which is generally at the top of the elevator shaft. When we press any button in a lift, the signal goes to the control unit and then it is translated through the system to tell the motor whether to move up or down. Once the elevator has reached its destination, there is a signal sent to the control room for it to either stop and let passengers board or exit it. Counterweight. It is a unit consisting of steel weights which counterbalance the weight of the car and to which the suspension ropes are attached. The weight of counterweight is equal to weight of car itself plus 40 to 50% of total weight it can carry. You can see in this picture, the car is located here. When the elevator car goes up, the counterweight goes down and vice versa, which helps in three ways. The counterweight makes it easier for the motor to raise and lower the car. Just as sitting on a seesaw, assuming the seesaw is properly balanced, you can bob up and down any number of times without ever really getting tired. Quite different from lifting someone in your arms, which tires you very quickly. Hence the motor needs to use much less force to move the car either up or down. Suppose the lift is loaded at its full capacity, which means it weighs more than the counterweight. But in this case, the motor has to lift the difference in weight between the two and supply a bit of extra force to overcome friction in the pulleys and so on. Since less force is involved, there is less strain on the cables, which makes the elevator a little bit safer. The counterweight reduces the amount of braking the elevator needs to use. Imagine if there were no counterweight. A heavily loaded elevator car would be really hard to pull upwards, but on the return journey, it would tend to race to the ground all by itself if there were not some sort of sturdy brake to stop it. The counterweight makes it much easier to control the elevator car. Guide shoes. Guide shoes are the devices which are used to guide the car and counterweight along the path of the guide rails. There are two types of guide shoes. One, roller guide shoes, roller guides, and two, sliding guides. Roller guides use rollers that rotate on guide rails. It has a set of three wheels that roll against the guide rails. You can see roller guide shoes on rails in this picture. Sliding guides. Guide shoes which simply slide along the faces of the rails. The sliding insert or jib may be metal, requiring guide rails to be lubricated, or may be plastic material which is self-lubricating. Guide shoes shall be made of cast iron, brass, or synthetic materials such as nylon, fiber-based hilum, etc. Sheave and motor. Sheave, also known as pulley. It has grooves in it and lets the rope be lifted, raised and lowered. It is the motor that keeps the sheave moving in the correct direction, taking people where they need to go. Speed governors. Most elevators have an entirely separate speed regulating system called a governor. which is a flywheel with mechanical arms built inside it. Normally the arms are held inside the flywheel by springs, but if the lift moves too fast, they fly outward, pushing a lever mechanism that trips one or more braking systems. First, they might cut power to the lift motor. If that fails and the lift continues to accelerate, the arms will fly out even further and trip a second mechanism applying the brakes. Some governors are entirely mechanical, others are electromagnetic, still others use a mixture of mechanical and electronic components. It is usually attached to the bottom of the car and it is also known as governor rope. Cable or rope. Elevator ropes are highly engineered and made of steel with other composites. Also, they are not single wires but several strands of various sizes wrapped together. A typical cable or rope can have over 150 strands of wire precisely designed to be strong, flexible, and give long life. Buffers. The buffer is an apparatus located at the bottom of elevator which is designed to protect people and malfunction of an elevator control system. Buffers can stop a descending car by accumulating or dissipating the kinetic energy of the car. You can see in this picture, buffers may also be fitted under the lift car or counterweight. Buffers can be of two types: energy accumulation type buffer and energy dissipation type buffer. Energy accumulation type buffers may be used only with lifts having a rated speed up to and including 1.5 meter per second. For example, spring buffer. Energy dissipation type buffers may be used whatever may be the rated speed of the lift. For example, oil buffer. Lift safety gears or brakes. Everyone who has ever traveled in an elevator has had the same thought. What if the cable holding this thing suddenly snaps? Rest assured, there is nothing to worry about. If a cable snaps, a variety of safety systems prevent an elevator car from crashing to the floor. Each car ran between two vertical guide rails with sturdy metal teeth embedded all the way up them. If the running speed of elevator car exceeds the set speed by elevator, or if the elevator suspension rope breaks down, elevator safety gear stops the elevator car and holds the elevator car at the elevator guide rail. Usually these brakes are installed on the elevator car or counterweight frame. Lift safety gears are of two types: instantaneous and progressive. If the car speed is less than 1 meter per second, then instantaneous type of safety gears are used. And if the car speed is above 1 meter per second, then these type of progressive safety gears are used. Capacity. To prevent overloading of the car by persons, the available area of the car shall be limited and related to the nominal or rated load of the elevator. For calculation of number of passengers, as per Indian standard, number of passengers is equal to rated load divided by 68. Here 68 is the weight of one passenger in kilogram. Whereas as per European standard, the average weight of passenger considered is 75 kg. Speed. What is the suitable speed of elevator? If it is too fast, then it will result in nervous breakdown to the user. And if it is too slow, then it will cause lack of function of electrical panels and power outlets. Cabin. It is also known as car. You can see in this picture, this is the main part of elevator which is designed for enclosed transport of passengers and goods. It is usually a heavy steel frame surrounding a cage of metal and wooden panels. Cabin is the place where the passenger truly experiences the elevator. Cabin can be of one opening, two opening, angle opening, and three entrance cabin. One opening cabin has a single entrance. Two opening cabin has two opposite entrances. Angle cabin has two entrances situated at an angle of 90 degree. And three entrance cabin has three entrances. Elevator cabinets shall be completely enclosed by walls, floors, and ceiling. The only permissible opening being are the car door, emergency trap door, and ventilation apertures. You can see in this picture, emergency trap door is placed on top of the elevator car. Car floor. Car floor shall have sufficient mechanical strength to sustain forces which will be applied during normal operation, safety gear operation, and impact of the car to its buffers. Floor will be recessed and covered by PVC covering or marble stone or granite, and it can be also customized according to client requirements. Car ceiling. Car ceiling is designed to be able to support two persons during maintenance operation without permanent deformation. Car ceiling is prepared also to mount emergency trapdoor, blower fan, and balustrade. False ceiling is the main source of lighting in the elevator car. There are many different designs for elevator lighting. Fluorescent lighting and spotlights are the most common lighting elements used for elevator lighting, and combination of two types can also be used. Emergency trapdoor assembly. Emergency trapdoor can be easily opened from inside the car by using triangular key and from outside the car without a key by turning the link to pull locking arms. Normally, emergency trapdoor size is 600 by 400 mm to permit the rescue and evacuation of passengers. Car operating panel, which is also known as COP. Car operating panel is a panel mounted in the car containing the car operating controls such as call register buttons, door open and close, alarm, emergency stop, and whatever other buttons or key switches are required for operation. Handrail. Elevator car in most cases is provided by a handrail at one side, two sides, or on all sides of the cabin. At least one side of the car has a handrail installed, which can be used by passengers for support, including persons with disabilities. Handrails come with different finishes like stainless steel styles or painted in selected color upon client requirements. Elevator doors. Elevator door is of two types, manual doors and automatic doors. Manual doors. These type of doors are opened with the help of person who wants to enter the lift. It can be a single panel or collapsible door that protects the car entrance. Automatic doors. Automatic doors are the type of doors which are automatically opened as it is powered by a door operator and usually have a full height photoelectric curtain to sense the entry or exit of persons. Automatic doors are of two types, central door, telescopic door. In case of central door, during opening or closing, the panels move in opposite directions. Whereas in case of telescopic door, during opening or closing, the panels move in the same direction.
Hope you have understood the mechanism. Now let's understand the evolution of the said mechanism and its public demonstration.
In the early 1850s, Elisha Otis invented a safety mechanism that changed everything. Let's take a look. This is a simple lift that can be raised or lowered by the rope. The safety mechanism is made up of a leaf spring, two pivot arms, and the teeth on both sides. When the lift is being pulled upward, the pivot arms are rotated, allowing the elevator to rise. But if the rope suddenly loses tension for any reason, the leaf spring immediately pushes the pivot arms down, which then comes in contact with the metal teeth. This stops the elevator from falling to the ground. Mr. Otis was so sure of his invention that he demonstrated it to a crowd of people at the World's Fair. He lifted himself up on the elevator and then had someone cut the supporting rope above. He only fell a few centimeters. This demonstration convinced the public that elevators could be safe enough for people to ride. Elevators today have multiple safety mechanisms in place, but it all started with Elisha Otis. The modern version of this is a little different, but the main idea is still the same. At the bottom of the elevator cab is the emergency brake. there are two clamps, and these are located on both sides of the guide rail. Normally they don't touch, so the elevator is allowed to move up and down. But if the lever is pulled, then they move in and grip the guide rail, which stops the elevator from falling. The lever is connected to a cable, and this is a separate cable from the ones that lift the cab. This cable attaches to another wheel at the top. Let's take a look. Back up here in the machine room, this device is called the overspeed governor. Normally, this spins along with the elevator cab as it moves up and down. Inside is a mechanism with two flyweights. Let's say, for whatever reason, that the cab starts to move downward too quickly. The overspeed governor will spin faster. If it spins too fast, these flyweights will move outward and catch the gear teeth on the side. This will stop the spinning, which stops the cable, and the weight of the cab now causes the lever to go up. And there's clamps on both sides of the elevator which firmly hold it in place.
Codes to be followed in India for supply and installation of lift or elevators. Please go through National Building Code 2016, Part 8, Section 5 for installation of lifts or elevators. If you refer the contents, most of the important aspects are covered there. Ride comfort. Ride comfort is measured in terms of vibration and jerks of the lift car in X, Y, or Z directions. Also, noise in car is measured. General. The appropriate aspect of lift or elevator installation shall be discussed during the preliminary planning of the building with all the concerned parties, namely client, architect, consulting engineer, or lift or elevator manufacturer. Here refer the typical flowchart on preliminary design of lifts. Typical arrangement of lift. Please cross-check all these aspects before proceeding lifts in your project. Essential requirements: various statutory requirements and additional requirements for passenger and goods lift as well as service lifts. Planning for dimensions. All planned dimensions of lift well are the minimum clear plumb sizes. Outline dimensions. The outline dimensions of lift shaft, machine room, pit depth, overhead and raw door opening size for lifts are indicated below. Schematic of outline dimensions. Dimensional tolerances. Lift well dimensions, landing door openings. Structural limits for lift wells at any level. Please refer this in detail. This is very important as far as civil construction is concerned. Energy efficiency and sustainability. Fire protection requirements for lifts. Buildings of height 15-meter and above, that is up to 60-meter. There shall be at least one fireman's lift per building. To be effective in firefighting operation, the fireman's lift shall have following requirements. Phase 1. Return to evacuation floor. Phase 2. Operation of the lift shall be as defined below. Buildings of height 60-meter and above. Indicative cost of lift or elevator work package. SOPs, that is standard operating procedures. First, it is pre-construction stage with concept stage. Traffic recommendations. Lift traffic analysis. Now, schematic stage. Indicative lift specifications. Lift finishes, front wall details, side walls details, rear walls details, landing view, ceiling, handrail, skirting, stainless steel finishes options, painted steel finishes options, stainless steel finishes options, etched stainless steel finishes options, landing call stations and COP, that is car operating panel, TFT LCD panel in COP in place of conventional, car position indicator surface mounted with box, various options, hall lantern surface mounted with box. Once you finalized all these options for your project, then get it recorded and circulated with all concerned to avoid any future ambiguity. Schematic stage continued. Now it is SOPs of tendering stage. Few important considerations during tendering stage. An indicative image of Tirak or Minifor required to install dummy lift for hoisting arrangement. Terms of payment, shop drawings. Defect liability period. AMC, that is annual maintenance contract. Labor law and Labor Act insurance policy. Safety, storage space, and statutory obligations. Work specification, order of precedence, escalation of rates, and as-built drawings. Name of few lift vendors. Execution stage. Client's scope of work. Before material dispatch. Before first stage and subsequently before second stage. As you can see here, a typical installation of lift door from lobby side, where the gap between masonry and lift door frames are considerably more, and we can't seal those gaps by appropriate sealant. We have to fix some sort of GI angles there. Also, as you can see, that hall call button or that panel installed there without the plastering done on the lift fascia, but the vertical level maintained appropriately. Also, you can notice that the flooring, as the final finished flooring not yet done, the temporary sort of flooring by means of IPS or sand cement plaster done to proceed with the lift installation works. So all these things are very important aspects in each and every project which we need to take care about. Before third stage, minor scopes, construction and commissioning of electrical power. Please note the followings. Lift vendors scope of work. Testing, commissioning and handover. Lift vendors project management plan. Special considerations for high-rise buildings. Building sway management. Impact of sway on lift or elevator design. Air pressure effect. Piston effect. building stack effect. Seismic design, power regeneration, power regeneration for different types of lifts, eco-efficient solutions, green building requirements, standby generator, BMS, that is building management system integration, seamless integration throughout the building, access system architecture, lift or elevator work package, management checklist. Thank you for watching. Hope you have found this video useful for your career development, knowledge upgradation, and use in your next project. Further, if you wish to implement the same in your building or project or property and organization and add or earn values, may contact us for further supports. Once again, request you all to subscribe our this informative channel and press bell icon for immediate all future updation and notification. Also share with your friends and contacts you feel will be of their use because sharing is caring. Thank you all. Hope to see you in next video. Namaskar.